All right, chapter 12, we're going to deal with three-dimensional figures. This chapter is it's a lot of fun. We're going to find area and the surface area of different figures and volume. To start, we're just going to get to know dimensional figures and what we're talking about. So you'll have some vocab on this PowerPoint, but there won't be a lot of homework for this specific PowerPoint. So anyway, 12.1 is three-dimensional figures. All right, we're going to identify and use three-dimensional figures. So, properties of a polyhedra. A polyhedron is a solid bounded by polygons called faces, which enclose a single region of space. So notice on the right you see the face on the top. An edge of a polyhedron is a line segment formed by the intersection of two faces. Okay, so there's the edge in the red. And a vertex of a polyhedron is a point where three or more edges meet. All right, so the vertex is on the bottom left. The plural of polyhedron is either polyhedra or polyhedrons. So identifying a polyhedron. Decide whether each of the solids below is a polyhedron. If so, count the number of faces, vertices, and edges of the polyhedron. So pause this and go ahead and do that and tell me which one's a polyhedron, the number of faces, vertices, and edges. Alright, so you should have found this. A is, it is a polyhedron. There's 5 faces, 6 vertices, and 9 edges. Alright, B, this is not a polyhedron because some of its faces are not polygons. Alright, and C, this is a polyhedron. It has 7 faces, 7 vertices, and 12 edges. So hopefully you get the hang of that. Now, types of solids. Of the 5 solids below, the prism and pyramid are polyhedra. The cone, cylinder, and sphere are not polyhedra. The prism has 2 parallel congruent faces called bases, and the other faces are parallelograms. The pyramid has all about one of its faces intersecting at one vertex. Both solids are named by the shape of their base, followed by prism or pyramid as their surname. So, an example: the triangular prism and square pyramid. That's how you would label those two. All right. If the bases of a prism are regular polygons, then it is called a regular prism. If all of the faces of a polyhedron are regular congruent polygons and all of the edges are congruent, then it is called a regular polyhedron. All right. So, there are 5 regular polyhedra called Platonic solids, named after the Greek mathematician and philosopher Plato. The 5 Platonic solids are regular tetrahedron. Okay, and see above, those are what regular tetrahedrons look like. 4 faces, 4 vertices, and 6 edges. We have a cube, a regular dodecagon, regular octahedron, and an isosahedron. Okay? Again, don't worry about too much of these. We're just going to really be dealing with the cube, triangular pyramids, and cylinders. So don't worry too much, but this is an example of what these are. So, identify the solid, name the bases, faces, edges, and vertices. Alright, this should be pretty easy. The bases are rectangles, and the 4 remaining faces are parallelograms. Okay, so this solid is a rectangular prism. Again, look what the base is. The base is a rectangle, so just put prism at the end of it. There are all the bases, faces, edges, and vertices. So make sure you pay attention. Go through those so you can see which one's which. Alright, how about this? Identify the solid, name the bases, faces, edges, and vertices. So the bases are circular and congruent. So the answer to this solid is a cylinder. The base is circle M and circle N. Okay? How about this one? The base is a triangle and the remaining 3 faces meet at a point. So this solid is a triangular pyramid. And there again, there are the base, faces, edges, and vertices. So go through those so you can see which ones are which. Alright, your turn. Identify the solid, name the base, face, edge, and vertice. It's a triangular prism. Again, the bases are triangles because there's 2 of them. There's 2 exact same things, so those are the bases. And then it's a prism. And the bases, faces, edges, and vertices are below. Alright, you guys should know this one. It's a cylinder, right? Circle N and M are bases. And this solid is a pentagonal pyramid. So again, it's a pentagon on the bottom, right, on the base. So it's just pentagonal pyramid. Alright, so cross sections. Imagine a plane slicing through a solid. The intersection of the plane and the solid is called a cross section. For instance, the diagram above shows that the intersection of a plane and a sphere is a circle. Okay, so if I was to take a basketball and I cut it right in half, and I flipped the basketball over so I could see what was on the inside, you would have a circle which was left, and that's like what a cross section is. Alright, so describe the shape formed by the intersection of the plane and the cube. So I cut that cube in half, and what am I going to get? I'm going to get a square, right? Because if it's a cube, all sides, so if I cut it in half, it's still going to be a square. Alright, how about this one? Describe the shape formed by the intersection of the plane and the cube. So now I'm cutting this cube across. So I'm going to have a pentagon, right? Because if you look at that, you can see the pentagon in there. Alright, this shape, right, should be a triangle. Okay? So that's an idea of what cross sections are. Now, a customer orders a 2-layer sheet cake. Describe the possible cross section of the sheet cake. So again, if I was to cut that in half, what would it be? Okay, if the cake is cut horizontally, the cross section will be a rectangle. If the cake is cut vertically, the cross section will also be a rectangle, right? So it doesn't matter which way you cut it. A solid cone is going to be sliced so that the resulting flat portion can be dipped in paint and used to make prints of different shapes. How should the cone be sliced to make prints of a circle, triangle, and an oval? Alright, so if the cone were to be cut parallel to the base, then the cross section would be a circle. If the cone were to be cut perpendicular to the base, then the slice would be a triangle. And if the cone were cut to an angle, then it would be an oval. Okay, so you guys get the idea of cross sections. So your assignment is going to be on page 825. You're to do 6, 7, 16 through 19, okay, and 25 through 27. So once you're done with that, then move on to the next video.